Hello everyone, this is actually the last part of the statistics video series, and the next part would be probability. So stay tuned for that tutorial as well. So understanding regression is really important, but because when you are understanding the machine learning algorithm, the first equation or the first method or the technique would be linear regression, because with linear regression we can find based on x value what would be the y. So based on one condition, what would be your another condition? Based on one variable, what would be the output of another variable? So we can predict different kind of things, and we can find good prediction using the linear regression formula or the equation. So an regression is actually an equation that expresses the linear relationship between the two variables. Okay, the linear relationship of two variables. It's just a perfect statement that two variables are correlated, and when one is increasing, one is decreasing, or one is increasing, another is also increasing. So this kind of relation they have, and the relation is y is equals to mx plus c. This is an actually straight line equation, or we can find y is equals to a plus bx. And as you can see in the equation, we have x and y, both of them, where y is the dependent variable, x is the independent variable, and m is actually the slope. This slope is actually the m, and c is the intercept of y-axis. This c is the intercept of y-axis. This is actually our y-axis. So here c is actually the cutting position or the intercept of y, and this is actually the slope of, and it is a positive slope because it is increasing. When the x is increasing, y is increasing. That's why our slope, this triangle here, is positive. But if it was negative, it would be like this way, and it would have been negative. So just to remember that y is equals to mx plus c equation, which is relationship between y and x, and when you put some value based on x, and it will give you some output in the y. So y is actually the functions of x. It is completely dependent on x. So we need to find the relationship of any equation based on this equation. So here is an example given: July, August, September, October. These are all the months, and add expenses 2, 1, 3, 4, and our sales revenue is given 7, 3, 8, 10 for different month. So you can express this one as x variable and this one as y variable as well, because dependent on your expense, what would be your sales revenue of that month. So we are understanding a mathematics based on it. This is a real life example of how we can understand the linear regression. So first question is determine the regression equation. So what was the regression equation? Y is equals to x plus b. So we need to find a and b on those variables. So if we find a and b, we can easily state an equation for the linear regression. So you would be given a data set of x and y. Based on it, you will find xi minus x bar and yi minus y bar. And for standard deviation, you need to find xi minus x bar whole square. If you want to find standard deviation of y, you need to find yi minus y bar whole square. So all of them are needed, and also needed xi minus x bar times yi minus y bar, which will be the multiplication of these two values. Sum them up and you get final answer 11. And standard deviation, this sum you get 26, and xi minus x bar whole square, the final output is 5. So x bar minus y bar is easy as hell, which is add them up and divided by number of items, which is 4. You just find them. And standard deviation is also simple, just this value divided root over this value divided by number of items minus 1. Number of items is 4, so 4 minus 1 is 3. So 1.29 is the ultimate answer. Same way you find the standard deviation of y. So always remember that for regression equation, you must have to find the standard deviation of x and standard deviation of y, because we need to find the r. So for finding r, we need to know this kind of things, and also we also need to know xi minus x bar, yi minus y bar summation value. So these two values are very important, and in every math you need that. So our correlation r, so we must have to find r's. That's why we are doing so many things. So xi minus summation of xi minus x bar, yi minus y bar divided by n minus 1 standard deviation of x and standard deviation of y. So you just put all those values and you find 0.97, which is a plus, and it is a strong correlation. because it is the range of between 0.75 to 1. So it is strong and it is positively correlated. When the x is increasing, y is also increasing. Now we need to find b and a. So those are the two parameters that are the most important. The formula to find b is the r times standard deviation of y divided by standard deviation of x. So we get the value of r from here, which is 0.97, and standard deviation of y is 2.94, and standard deviation of x is 1.29. And a is actually the y bar minus bx. So y bar is actually simple. From previous data set we find the y bar minus b is actually the 2.21, and x bar is also there, so 2.5. So this is your 1.5 is actually the value of a, and 2.21 is the value of b. Now this is our main equation, y is equals to a plus bx. Now value of a is this one and the value of b is this one, and your x. Now you find the ultimate y and x equation, the total equation, and this equation tells the relationship between your x and y. Your second question was intercept the values of y. This is done. And estimate the sales when 3 million is spent. When you spend $3 million, how would be your sales revenue? Because we just captured a equation where we can find the value of x, and we give the value of x and find the y. So this is your x and this is your y. You need to find that estimate sales. You have to estimate this one. This is actually the y when you spend an ad expense of 3 million. So this is your x. So you have given your x. Now you need to find the y for that particular reason. A is actually $1.5, which is free from sales revenues, because this one is actually the constant. So 2.21 ad expense is increased by 2.21. This is your solution. As also you need to estimate for $3 million you are estimating. So y is equals to a plus bx. A is 1.5 and b is actually the 2.21, and 3 is your x variable. So if you are given the x, what would be the y? 8.1. So if you spend 3 million, you would be getting a sales revenue of $8.1 million when you spend 3 million. Okay, so if you want for 5, what would be your revenue? You can find that as well. So if you just state an equation for x and y variables for given your data set, you can find any of your predictions. Suppose it is 5, you get your predicted output. If it was 10 million spent, what would be the revenue? You get that. So in real life situation, this equation is really important and very important to understand, especially for machine learning, artificial intelligence, and many kind of data science related work. And now another one is given for an example, like distance. This is actually the y variable, and number of customers visiting is the x variable. So you just plot a graph. So number of customers in the x variable, and number of and the distance is the y variable. So you need to find the regression equation for x and y variables. So for that you need to find a and b first. If you find a and b, then you find that equation for these data sets. Now there is another question number 3. To receive 5 customers, so your x is given. At what distance from the center the shopping center be located? So you would be given the number of customers, which is x, and based on it what would be your distance. You need to find that. So let's solve this 3 first. Your x is given. This is your x values, this is your x values, and this is your y values. So as usual, you need to find xi minus x bar, yi minus y bar, xi minus x bar whole square, and yi minus y bar whole square. And also to find r, you need to find xi minus x bar times yi minus y bar. So this 1 2 3 4 5 6 7, those 7 things are always be needed when you are finding linear regressions as well, and also if you want to find the value of r. And as you see, all of your values, for finding standard deviation, you need xi minus x bar whole square, and also yi minus y bar whole square. So these 2 things are needed, and also x bar and y bar is also needed. And this is your if you want to find the r, so xi minus x bar, this summation is also needed. So here you have x bar, y bar, standard deviation of x, which is root over 26 by number of items minus 1. You get that, and standard deviation of y. And you need to find r same way as before. So this is minus 1.008, so it is negatively correlated. and it is very strong correlation because it is it is range -1. So it is very strongly correlated and negatively correlated. When one is increasing, when x is increasing, y is decreasing. When y is increasing, x is decreasing. So they are negatively correlated. One is increasing and another is decreasing. So standard deviation b is actually the r standard deviation of y divided by standard deviation of x. You find that. And if you want to find a, which is y bar minus bx, y bar is this one, x bar is also there, and the b is that thing which is minus 0.04. When you find the b and a, those two formulas are important, keep remember that. When you find the b and a, you get this equation, and your ultimate equation y is equals to a is actually the 201.53 and the b value is minus 0.04 and times x. Now you have given a is equals to 201.53. So 201.53 is actually the constant here. So this miles distance is free from the effect of number of customers. So this number of miles does not affect the number of customers. Distance will be denoted by 0.04 distance, because distance is actually our y variable and number of customers is our x variable. So 0.04 for 1 unit increase of customer. So if you increase 1 unit of customers, the distance would be minus 0.04. So now question number 3 is very important, because they are given that there would be 5 customers. So number of customers is a x variable. So how many distance they need to cover? So you need to find y, which is 201.53 minus 0.04 times 5. So 201.33 miles distance they need to cover if you give 5 customers to it. And you can put any number, 10, 15, 500, and you get the distance. Our question number 4 is how many customer will visit? So our customer will visit, number of customer visit, so we need to find x. So we would be given y. How many customer will visit if distance of shopping center is 9 miles? Distance of shopping center is 9 miles. We have given 200 miles, 300 miles, 400, 800, 180 and 120 miles. So now you need to find for 9 miles. So our y is given, we need to find x. So our y is given, y is equals to a plus bx, b's values is minus 0.04 times x. So minus 0.04 x, we just taking it here, and 9 minus 201 is there. So our ultimate answer is I will just divide 9 minus 201.53 with this 0.04. Always keep remember that it is minus 0.04. So our ultimate answer is 4813.25. This is the number of customers will visit when you are giving a distance of 9 miles. Okay, so when the distance is smaller, the huge number of people will come to visit your customers. So the customers visiting will be increasing when your distance is very low. But when you increase the distance, the customer attendance would be lot less compared to this. So there is a decreased, so there is inverse relationship between them. One is increasing, one is decreasing, and one is increasing. When the distance is 9 miles, okay, so your y is given 9 miles. How many customers will visit? 4,813.25 customer will visit. So you just round them up because the customers are just round values. So 4813 is actually the number of customers that will visit if the distance is 9 miles. So these are the things that very important to understand in regression equation, because you can predict based on one variable and find another variable. So this is very important to learn. So this is all for statistics video, guys. I hope you like the videos and wait for the probability distribution as well. So thanks for watching, guys. I'll catch up with the next video.